In this video, we're going to take a look at how we can solve a quadratic by completing the square and leave our answer in exact form. Looking at the example on the left-hand side, the first thing we need to look at is the coefficient of x. The coefficient of x in this case is 2. Halving this value gives me the number that goes inside the brackets of the completely squared form. We still have minus 2, but we need to take away the square of the number that's inside the bracket. So take away 1 squared. One of the main reasons for this minus 1 squared is that when we expand x plus 1 all squared, we end up with 1 on the end of our expression. Then if we take away 1 squared and take away 2, we end up with the original quadratic that we started with. Remembering this is equal to 0, and simplifying negative 2 take away 1 squared gives x plus 1 all squared take away 3 is equal to 0. This quadratic is now much easier to solve by rearrangement. So adding 3 to both sides would give x plus 1 all squared is equal to 3. Taking the square root of both sides gives x plus 1 is equal to plus or minus the square root of 3. And then taking away 1, x is equal to negative 1 plus or minus the square root of 3. This means that x has two values. X will equal negative 1 plus the square root of 3, or x will equal negative 1 take away the square root of 3. We've now solved the original quadratic and left it in exact form through using surds. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. So the coefficient of x in this case is negative 4. This means inside the brackets I'll have x take away 2 all squared, take away 4 and take away negative 2 squared. Remembering this is equal to 0 and simplifying negative 4 take away 2 squared gives x take away 2 all squared take away 8 is equal to 0. Adding 8 to both sides and square rooting then adding 2 gives x as 2 plus the square root of 8, and x is equal to 2 minus the square root of 8.